Welcome to our lecture number 2. We want to discuss about intersection of surfaces or interpenetration of solids. Let's see how this is formed. So we have a line of intersection of two surfaces, which is found by determining a number of points common to both surfaces and drawing a line or lines through these points in the correct order. So when two solid interpenetrate, their surfaces intersect, and at the junction of intersection, a typical curve is formed, which remains common to both solids. And this curve is termed as intersection, and it is a result of interpenetration of the solids. So why these curves becomes important? When two objects are to be joined together, so the maximum surface of contact between both becomes a basic requirement for the strongest and leak-proof of the joint. So the curve of intersection, being common to both intersecting solids, indicates the exact and maximum surface contact of both solids. Here is an example of some common objects that are found in our daily life. You can have a small cylinder intersecting the bigger one here. So the interface or the curve, which indicates how they do intersect, which we have placed it in the first part, that is, it is very important to ensure leak-proof and strong joint. So we should have a strong joint here to ensure no breakage, no leakage. So you can see these arrows is provided to indicate where the curve for interpenetration is formed. So you can see how here is formed regarding this prism and a cylinder, cylinder to cylinder. As you can see here, cylinder to cylinder. Here, how it is formed. So first, we have to demonstrate a standing cylinder being interpenetrated by a horizontal cylinder, which is smaller in size in comparison to the standing cylinder. See on how they form the curves, and this is, as well said, is to ensure a strong joint and no leakage at all. So how to obtain the curves by construction on sketches or drawings. So we need to use the dimensions provided in our case. We have to draw first the plan view for our two cylinders intersecting, interpenetrating. As you can see, this is the standing cylinder and this is the one in horizontal interpenetrating the standing cylinder. It's very, very important to draw the end view of it, end view, for the sake of having the divisions of the cylinder here. As you can see, the circle for the cylinder that is in horizontal, it has been divided into 12 equal parts. You can see 12, 6, 10, 12, 10, 4 to 10. They are in line. It's very important to note here. 2 is in line with the 8. 3 is in line with the 9. So this to note is very, very important when it comes for the plan view. You can see 2 points at one, 2 numbers at one point, like 4 and 10, 7 and 1, 2 and 12. One thing to note here is where is the position of 1 and 7 for the plan view, and what happens when it is for the front view. They do alter, as you can see. 1 and 7 is at the center for the front view, but when it comes for the plan view, these points are altered to the ends of this plan view, and it becomes 4 and 10 at the center, which were at the ends of the semicircle. So it's very important to have a semicircle here, likewise for the front view. From these points on the plan view, we have to project lines until when they touch the standing circle for the standing cylinder. This is our plan view. So we have to project horizontal lines here. You can see from 1 here, from 7 it is here, and from 4 and 10 they are projected and they meet somewhere here at the surface. Likewise 3 and 11 here, 2 and 12 somewhere here. So being 2, it indicates that they are in the same line. So after they have been touching the circumference here, they will have to change the direction downwards. So they are projected downwards. From the semicircle, which is laid on the front view, our front view here, so it's laid here. So we have to project these numbers labeled here, 4, until when it meets the 4, which is in our plan view. As you can see, 4 is here. So if we project downwards here, it would meet here. This is our first point here. Likewise for 10. 10 from the same point, projected downwards, it meets another 10 here. That's how we obtain the point of intersection, which forms the curve for interpenetration of the two cylinders. What has been done for 4 and 10, 7 and 1 is the same for the left other numbers, which is 2 and 6, 3 and 5, 12 and 8, 11 and 9. You can see those numbers in the front view here, must intersect here after being projected from the semicircle on the plan view, projected downwards. After they have intersected this curve, they have to go downwards until when they meet another number of the same number, that is 2 from the front view, 2 from the plan view. They have to meet somewhere and form a point for our curve. So the same procedures for a cylinder that is standing, being interpenetrated by another cylinder inclined at a given angle. For example, here, if we regard our axis for the cylinder that is interpenetrating, the bigger one being laid maybe at 60 degrees, the same procedures will be conducted. You have to do to construct a semicircle. One thing to ensure is the base of this cylinder should be parallel with the base of a semicircle. Should be parallel. You can see parallelism is here. So half circle to be divided into 12 equal parts, or 8, that is of regard to your interest. For this case, they are divided 12. So if this semicircle for the front view is labeled like this, same procedures will be conducted for the plan view. You have to remember that they do change, they do alter. Those which were at the center will be at the outer part of the semicircle. For example, 1 and 7, they are at the center in the plan, but for the case of front view, they are the ones at the ends of this circle semicircle 1 and 2, as you can see, but they have to follow the procedure. How? If here is 1, make sure it's followed by 2, 3, 4, 5, 6, 7. Then it continues 7, 8, 9, 10, 11, 12. That is the order we are regarding. So the same for plan view. And this is the end view of your two cylinders interpenetrating each other. That's how it looks like if you observe from the end view. Another example is provided here, whereby the angle of interpenetration is provided, measured from the vertical axis for the standing cylinder, as you can see. But how to get the curve are the same procedures. You have to draw a semicircle that's very, very close to the base of the cylinder that is interpenetrating. This circle, you have to note that the points and the numbers laid here will change position when they are laid for the plan view, as it has been explained for the previous cases. Likewise, for this side, you have two options. You can use the same line to the other side to get this curve, or you can label another semicircle to obtain this curve here. Yeah, so that's how one can get this line of interpenetration of the two cylinders. We have another example, which is a cone and a cylinder. This cylinder is interpenetrating a standing cone. How to go? First of all, you need to construct the plan and front view for the two cases. Drawing this, first of all, you need to draw it as it is by construction line. Construction line for the entire cone, standing cone, and with its line or horizontal cylinder. This procedure is followed by drawing the end view. How is this cylinder located for this standing cone? This is the center where this cylinder is located. Then it's followed by dividing this cylinder into parts that are equally spaced. For this case, they are divided into 8 equal parts. As you can see, the number 1 up to 8, so they are divided into 8 equal parts. After you have divided this, you have to project those numbers, as you can see, to the front view here. Front view. Yeah, here. They have been projected, but one thing to note, there are numbers that do happen. There are two numbers are in line. For example, 2 and 8, they are in line. So they are projected within one line. This is number 1, as you can see, it has been projected, is on the surface of this cylinder, touching this point and this one here, followed by 8 and 2. 2 and 8, they are forming this line here, the line that it seems to be thicker, somehow thicker. But where did you get this? It has been projected downwards until when it reaches the line that is lying at 45 degrees from the horizontal. How do you obtain this? After you draw from the base, the horizontal line that is forming the base of this cone at 45 degrees. When it touches this, it has to draw You have to divide this, as we said, into 8 equal parts. 8 equal parts. So the 8 equal parts, as we laid here, you have to remember how is obtained. So this line that is for 3 here, you get this line here, then you have to project it upwards. So this is how you can obtain the lines for intersection for a cone and a cylinder. The same procedures for a standing cylinder being interpenetrated by a cone. Here is simple. Why? Because we have to have a semicircle here for a cylinder. Why? A cylinder have got a circle at the base. So this base of a cylinder will have a semicircle for the front view, likewise for the plan view. This semicircle will be divided as we did for the cylinder to cylinder interpenetration. So you have to divide into a given number that the parts will be equally spaced. For this case, they are 8 in number. So as I have said for the first case, that those points which are at the center, you have to ensure that when it comes for the front view, they have to change position. It's 3 and 7 at the center, following the order. So here they are at the ends of it, the same circle here. So it's 3 and 7, like whereby at this plan view, 3 and 7 is located at the center. But they have to follow the order as we said. If 1, 2, 3, 4, 5, 6, 7, 8. Likewise here, 1, 2, 3, 4, 5, or 5, 6, 7, then 8. That's the order we are focusing. So now you can easily get where they intersect. How? If you project until when they meet this base. From the base, you have to project a line searching for the apex of the cone, but before reaching the apex, it has to intersect the cylinder. This point is very important. It's where we can change now the direction upwards, where it's going to meet another line that has been projected from the semicircle here, meeting the base, and from the base is going to the apex. This same line here, if it was number 2, for example, from the same circle here, number 2, then projecting to the apex of the cone, but in between it has intersected the surface of the cylinder. So here is where we get the changing of direction, going upward until when it meets another line of number 2 from the same circle. This is our point of interest. This is our point of interest. Likewise for other points, let's see for 8. 8 is the same line and 2, so the same line. So you can see here is our point of interest. It has come to meet another 8 from our front view semicircle, front view semicircle, plan view semicircle. Yeah, that's how we can locate those points. It is the case of 7 from the same circle of the front view, meeting 7 of the plan view. As you can see here, it's located here and here because they are in line. So it is 3 one side and 7 on the other side. That's how one can obtain the curve for this case. You can see same procedure here from those lines, as we have said, from semicircle, they have to be brought somewhere there. Until when they touch it, they have to be projected upwards. After being projected, they are not indicated here just for the matter of being neat sketches. They would have been projected from the same points in order to get them here and projecting upward until when they meet the same numbers 8. So here in the case of 6 here, you would get it somewhere there. Yeah, another example is the standing cylinder being interpenetrated by another solid material, which is square prism. It's very simple here to locate the points. Why? After you have drawn clearly the construction lines for the plan of your two objects, likewise here the outer lines can be constructed very easily without regarding those points. First of all, you need to construct it looks like. So you construct the end view. It's very important to construct this one. Why? You see the source of our points where we reimage the lines and project them to the line which will lead us to the plan view. And from the plan view, we have a point of intersection with those from the end view. It's the same procedure as we did for cylinder to cylinder. So here, you don't have to have a semicircle. Here you use the points given the corners of a square prism, the base of a square prism that is interpenetrating the cylinder. So A, B, C, D, these are very important to note. They will be projected downwards until when they meet this line, which is laid at 45 from horizontal, then projected to the plan until when they meet the cylinder. They are from the prism, mind you, this is the prism. Now they are brought to the intersecting the cylinder. So when they touch this surface of the cylinder is our point of interest. So we need now to project upwards to meet the same line. This line is imaging here. B goes down there, then projected upwards. Then from B again is projected to the front view. So they meet at the front view. They are starting from the end view with the two rods. One rod goes to the front view, another rod goes to the plan, then back to the front view. So at the front view is our interest to indicate how is being intersected, how a curve of intersection or interpenetration is formed. So C is here, you can see C. Then you project upwards, you meet another line from the same C here. So one thing to note, here it's not a straight line C to D or B to A. Likewise, B to A, B to C is not a straight line, it's a curve. Simply, we are because we are having a standing cylinder being interpenetrated by a square prism. So it forms a curve at the point of intersection. It forms what? A curve. Let's see another one. This case is for a prism to prism. For a case of prism to prism, it's not very much difficult to locate the points. The only difference is that we have to label after we have drawn the three views, that is a plan view or top view, front view, and end view. From the end view is where we have to project the lines. As you can see, the arrow from B until when it meets it meets another one. This one in this yellowish color. So now we have to project a line from this yellowish to the this color, which is bluish. So from the yellow to bluish, you have to remember that we are projecting from this material until when it intersects another material. So this is a material that is in horizontal position. This one is in vertical position. When they do intersect, you have to return them back until when they meet with another line. So for our case here, this is B, it meets here, then you have to project upwards. So from this sketch, you have to remember that no need of drawing here because these points are in the same line. So the two are given to you for representation. So B and D are in line, the same line, same level. So they are here. How do you obtain it? After you have drawn this line up to the plan, at the plan, where does it intersect? Is here. So you have to project upwards until when it meets the same line from B. Yeah, you can see. Likewise for D, D is here. It meets the standing prism. Then you have to project upwards until when it meets a line which is coming from the same point D. I hope I made it clear. Thank you for watching this. See you next time.